We're on example 2, lesson 1-3. This is incorrect up there. So lesson 1-3, we're going to graph a piecewise defined function. And for you, this could be tough. All right, is this your first look at a piecewise function? Yes, okay, good. So what we have here are 3 different functions all being graphed on the same sheet of paper at the same time under different, what might we call these? The x goes from here to there. The x goes from here. The student said domains. Yes, under different domains. So we're going to graph these 3 functions under these 3 domains. All right? Notice how the domains work. In the first one, you're going to let x go from -10 to -2. Then the second one down picks up when you go from -2 to +2. Then the third one kicks in when you go from 2 to 10. So do you see how the domains kind of spill right into each other, right? One goes up to -2, then the next one takes over to 2, then the next one takes over up to 10, all right? So on your graph paper, what we're going to do is we're going to begin by taking the leftmost x value, -10, and we're going to plug it into this equation to see what we get. We're going to take -10 and plug it in and see what we get. So x, y, -10. We're going to call this the red equation. What do we get when we do -10 times 4 plus 11? -10 times 4 plus 11. Who says 29? No? 29, okay? -10 comma 29 would be the point to the farthest left on our graph. 19? -29. Thank you. -29. Let's put in -9, -8, -7. Do we have to put all these points in? Why don't we actually just go to maybe like -3? Why might we go to -3 for this first equation? It's right next to -2. -2 is a key point here. -2 is sort of the boundary before we jump down to the next equation. All right? And technically, should -2 be in this red equation, or is -2 actually in the second equation? It's in the second because of this little symbol. -2 actually belongs in the second domain. So we're going to cut the red one off at -3 and see what we get. What do we get when we put in -3 times 4 plus 11? -3 times 4 plus 11 is -1. Okay. Now let's play a little what if. What if -2 was allowed to go in to the red equation? Let's do it. Let's be rebels here, and let's put -2 into the top equation just to see where that first line stops. Here's why. Is -2.5 in this domain? Is -2.5 between -2 and -10? Yes. Is -2.1 in that domain? Yes. Is -2.01? Yes. So we want to see where this thing ends when you get to -2. We'll just put an open dot there. Get it? You know those open dots? That means you go there, but you don't actually touch that point. So what do you get when you put in -2 times 4 plus 11? -2 times 4 plus 11 is 3. We're going to have a closed dot here and an open dot here and a line connecting them. All right? Should we graph it now, or should we move on to the next table? We'll graph it now. If you're watching from home, I'm going to pause the video and you'll see the graph magically appear. Here we go. We have a graph of the first piece of this function. It's in red. It's got an open circle at -2, 3. And what we noticed was it has a slope of 4. This is the equation with of a line with slope 4. And oh, by the way, this is for everybody here. What would its y-intercept be? 4x plus 11. What's the y-intercept? 11. That's the point at which this line would hit the y-axis if you could keep graphing it. If the domain wasn't cut off here at -2, do you agree that this line would eventually go up and strike the y-axis? Guess where? 11 is where it would hit, okay? So this is basically just the line 4x plus 11, but we're just looking at a segment of it. Now, if you're watching on the video, my paper wouldn't allow us to get all the way down to the point -10, -29. If my paper was big enough, there would be a closed circle down there stopping the graph. Moving on. Let's get rid of the red. Let's make the next part green. Let's do some x's and y's from -2 to 2 in this function. So this is like saying when x goes from here to here, be on the red line. When x goes from -2 to 2, be on the green parabola. So what do we get when we put in -2, square it, and subtract 1? 3. Put in -1, square it, and subtract 1. 0. Put in 0 squared minus 1 is -1. Put in 1. And put in 2 squared minus 1 is 3. You should see symmetry here because this is a parabola. Let's go ahead and put dots. At -2, 3, we're going to put a closed circle. There's already an open circle on that spot. So they have a fight. There's a fight between the open circle and the closed circle. Guess who wins? Closed. Close it up because that point exists on this function. The point -2, 3 is where this function lives. If this would have been a different equation, maybe it would have just been x squared. Maybe you'd have a closed circle here and an open circle there. But in this case, it's on the same spot. Finish plotting the points. Can I close my last point? Check your domain closely. It says when x is less than or equal to 2. So this point actually exists. So we have closed endpoints and everything in between. Trace it, and we're getting there. We're 2/3 of the way done graphing our first piecewise function. Here we go to the last one. We'll do it in blue. Looks pretty easy. It's just the line x plus 1 from 2 to 10. From 2 to 10. I like using the table just so we can sort of see what's happening here. When you put in the first point you're allowed to put in, realizing that it's going to be an open circle, right? What would you get if you plugged in 2? 2 plus 1 is 3. Put in 3. 3 plus 1 is 4. Put in 5. Keep going until you put in 10 and get 11. So here we go. By the way, at 10, 11, it would be a closed circle. We're going to see this piecewise function come to form here as I put my open circle at 2, 3. There's already a point there. Should I keep it closed? If there's an open and a closed circle at the same point, keep it closed. If you have different colors and you want to draw it like I did, that's fine. Understanding, though, there's a point there. All right? The next point is at 3, 4, 4, 5, 5, 6. Keep going until you get to 10, 11. Make a line. This is a closed circle, meaning it stops there. If there was an arrowhead on the end, that would mean it keeps going forever. But we stopped it like a line segment from geometry, meaning that the domain is closed. It ended at 10. This is a complete graph of example 2.